question here. This next question, they are saying the following, right? They say it here, from our picture, let me actually copy the picture again so that we don't have to keep going up, down, up, down, up, down, you know. They said the following: prove that the lengths of PA, so let's identify those lengths. So we have PA, which is this line over there. Let me see here. There's PA here. Okay, that's PA, fine. Let me actually maybe get something a bit brighter. PA, and then you have PR. Use a different color for PR. PR is here. And then you also have PB. So there's PB over there. Where's PB now? Let me get a blue. PB is where's PB? Oh, thing is jamming. Why are you jamming now? PB is the big one here. So this may just be a 3-mark question, yes. The one thing we can also see is that this question, there are no dimensions given anyway. But then they are saying we should prove that line PA, line PR, and line PB in this order form a geometric sequence. So we're dealing with a Euclidean geometry question, but then you can see here, they're talking about a geometric sequence. And that's like paper 1. So this question just highlights the fact that it doesn't matter if you're doing paper 1 or paper 2. All the knowledge that you know can be utilized to answer whatever question they're asking. So the first thing is a geometric sequence. We know that you have a common ratio where T2 over T1 is equal to T3 over T2. So this is what you can lean on. The reason why you want to lean on this expression here is because anytime you're doing anything, always try and think based on, you know, the topic that you're working with. Like here we're working on Euclidean geometry and we have just proven similarity here. Anytime you've proven similarity, don't forget your proportionality theorem, because anytime you've proven similarity, right? Let's write down these two triangles here. We've proven that these two triangles are similar. So automatically, just because we've proven that these two triangles are similar, we already know that based on our proportionality theorem, we already know that line PB over line PQ, this is equal to line BC, line BQ over line QA, and then all those two are also equal to PQ over PA. You see, this is writing this out. Our reason will just be the proportionality theorem, proportionality theorem. You see, so after reading this question, the first thing to do was to just see that we are trying to say that these lines form a geometric sequence. And the only way something can be a geometric sequence is if T2 over T1 is equal to T3 over T2, of which, remember, they said these form a geometric sequence. So automatically we know that we're dealing with T1 here, T2 there, and T3, you see. So our job is to just show that based on this expression for a geometric sequence, our job is to just show that PR over PA is equal to T3 here. We've said it's PB over T2 here, which is just PR. You see, our job is to just show that this expression exists. You know, we just need to show that this expression is correct. And as long as this expression is correct, and as long as we can write out this expression from the knowledge that we have of our sketch, as long as we can end up with an expression like this, then we will be good to go. Like we'll be able to, we'll be done with this question basically. Now, the one thing I can say is anytime you're going to answer questions like these, right, always analyze the information that they've given you and always analyze the sketch that you're working with. Like here, you can see that don't also think too far from what you have worked with. Like here, we were talking about these two triangles. Now, these two triangles, we already know that it's these ones here. It's this triangle here, the small one, and then it's the big one here that I'm going to put in blue. Now, the reason why I'm talking about these two triangles again is because I want you to remember the fact that anytime you're going to answer any questions with Euclidean geometry and you see that there's stuff to do with proportionality and you have proven similarity, anytime you have questions like that, try to work more with the triangles that you have information for. Like we're going to need to work with these two triangles to help us with this question. Now, the idea is here they spoke of these three lines, but then the issue is PR, it's just a random line, you see? So you don't want to use PR as PR. What you actually want to remember for yourself is that here they could be talking about PR, but then remember PR is equal to PQ, you see? So even though here there's a PR, you could automatically even be seeing a PQ over there, you see, so that when you're going to be doing whatever you're doing, it's easier for you to work with PQ. And then once you have what you have, you can then replace the PQ with PR to have whatever expression you need to have when you're done with the question, you see. So what I'm trying to say is work with these two triangles and use PQ, you see, because whenever you're done, right, you'll then be able to replace PQ by writing PR because they are equal to each other. Does that make sense? Yeah. So even with this expression here, right, we can view it as where PR is, we can think to ourselves, we need to come up with an expression that has PQ here, and then it has PQ at the bottom there, and then it has PB at the top there. This is the expression we need to come up with, you see? Because as long as we can come up with this expression, it will be equal to this thing here, you see? Because we know that this is T1, this is T2, this is T3. We already know that as long as this is going to be a geometric sequence, it means that T1 over T2 has to be equal to T3 over T2. So we said where T2 is, we just wrote PR there. Where T1 is, we wrote PA there. Where T3 is, we wrote PB there. Where T2 is, we wrote PR there. So we said the PRs here, they're not helping us because they're just random lines, you know? It's just a random line. So it's easier for us to maybe try and get this, because the moment we get this from using whatever laws we have, then we're practically done, you see. So that's where this comes in, you see. This is going to help us here because from writing these three, we just have to pick out which two of these are going to give us this that we need over there. You see, because what we need here is something that is PB over PQ. And we have it here. What we also then need is something that is PQ over PA. And we have that here, you see. So for this question, all we can see is we just wrote down our proportionality expressions, and we have to just pick out two of these here that we can work with, because you can't work with all three at the same time. So here we can say PB over PQ is equal to PQ over PA. You see, we wrote this out because of the proportionality theorem. So this is obviously a mark, you see. The next thing we're going to do is we are going to replace the PQs with PR. You see, so here we can say, therefore, we know here, oh no, we don't have to say therefore, we can just say PQ is equal to PR. The reason is proven. We proved it already because we want to replace the PQs with PR, right? So before we can just do it, we need to give them a reason why we are about to do it. So we're saying that PQ is equal to PR here. The reason is we proved it. And it was proven way in the past. The very first question even, you see. Even if, say, this question was too difficult and you maybe did not get it, here down here, you can even still use it as a reason. Because I mean, like, anything you would have had to prove here, it means it's correct. you see. So us saying that these are equal, we can then say, therefore, where we see the PQ there, we can just replace it with PR. And then where we see the PQ there, we can just replace it with PR. So you see, now we have this expression, you see, and this expression clearly has the lines that they are talking about here, PA, PR, and PB, you see, PA, PR, and P, no, I made a mistake here. What am I doing? I wrote the wrong thing. I wanted to replace this PQ and that PQ. So it's PB at the top. This is going to be PR. And then this is PR here. And this is like PA. So as long as we've done this, right, here we can say, we can now safely say that PA, PR, and PB, PA, PR, and PB form a geometric sequence because T2 over T1 is equal to T3 over T2, you see, because in this order, this is T1, this is T2, this is T3, you see, and we have shown that this over this is something we can come up with. And we have also shown that, yeah, no, I think I did, yeah, this over this is obviously this that we have here. And then this over this is obviously this that we have over there, you see. So that's literally all we would have to do for 3 marks. You can see for the 3 marks, we have our expressions here. This is equal to this. And we wrote it out because of our proportionality theorem. Secondly, we said PQ is equal to PR. That was proven already. And then when we see the PQs, we were able to replace them with PR. Having to have done all this, we can now say this is definitely a geometric sequence because the law of a geometric sequence is being proven, like we proved it, you see. We showed that the term here divided by the previous one will be equal to the term here divided by the previous one. And then they'll give us 3 marks. Before we even started, we just had to clarify what this means and why they are saying it. You see, anything your question is going to tell you, use that as ammunition to like answer the question. Because the moment they mention geometric sequence and us proving that these lines form a geometric sequence, we just needed to end up with this expression. And us needing to end up with this expression, we said, okay, all we need to know is that T3 over this should be equal to that over that, which gives us this expression. And then from this expression, we already said that the PRs, it's not somewhere in our sketch that is inside like similar triangles and all that. But then our backdoor here was the fact that PQ is equal to PR anyways. So wherever we saw the PR, we say to ourselves, okay, let's just aim to get an expression that looks like this one. Because as long as we have an expression that looks like this one, we can eventually just write out this, you see. So we firstly got an idea of what we were going to do, and then we started doing it, you see. The proportionality theorem gave us the ratios that we need. And then the PQs here, we said they were not going to help us. So we replaced them with PR because the PR and the PQ are equal. And then after doing that, we have the expression that we know we needed, you see, because that expression has to represent this. And we showed that it actually does represent that. And then that is how we got this answer. You see it? Yeah, so I can safely say that this is one of the not so nice questions, but you can see how whatever they're going to ask you, you don't want to overthink it and you don't want to think too randomly. Meaning, if you see this question and you don't have a good feeling about it, your best bet is to move on to other questions and only come back to this when you know that you've clearly gone through everything else that was going to get you marks without thinking too hard. Cool.
Yeah.